Hello viewers, welcome to the session from Learning with Patel for understanding what is confusion matrix. So we all start who are involved in machine learning or working out models for AI. We all might have been seen or used or try to use confusion matrix. Just try to work out on the finer details like what is confusion matrix, how it helps us, and what do we conclude, what kind of conclusions that we derive looking at the confusion matrix. Yeah. So if I go and say like trying to understand what is the confusion in confusion matrix, right? So trying to demystifying that. So what is confusion matrix? A confusion matrix is a table that is often used to describe the performance of a classification model or a set of on a set of test data for which the true values are known. So, what is a classification model? A classification model is where we take a set of records, a data set, and we try to classify it. Like, if you have been working with any machine learning and artificial intelligence studies, you might be aware of an data set called as Titanic data set, where we have a list of passengers and whether they survived that mishap or not. So that is what we are. That is called as classification, where we classify whether that passenger has survived or not based on the data that we have. So confusion metric is something which can help us in that, and it allows us to visualize the performance of an algorithm which we derive or which we train our model to use to do this kind of classification. Yeah, and we can test our model using a test data. Yeah, and then we build a confusion matrix based on that particular test data to measure how our algorithm or how our model is performing. So that is what confusion matrix is all about. What are the contents of a confusion matrix? So if you look at a confusion matrix, there are basically four quadrants. So there are four quadrants. So let's start what each quadrant means. And so first quadrant we go with is true positive. So true positive is an outcome where the model correctly predicts the positive class. So what is a positive class? Suppose going by our same example of Titanic dataset, a passenger has survived the mishap and our model predicts the same. Yeah. So that is what is positive class, and the model predicts okay that passenger has survived. So that is a true positive. Next quadrant is true negative. So is an outcome where the model correctly predicts the negative class. Like suppose a passenger on Titanic has not survived, and our model predicts the same. So that is true negative. Next quadrant is false positive. So in an it is an outcome where the model incorrectly predicts the positive class. So in actual the passenger has survived, but our model suggests that he has not survived. Then that is a false positive. A false negative is an outcome where the model incorrectly predicts the negative class. So suppose for a particular passenger, our model predicts he has not survived, as a matter of fact that passenger has survived. So that is a false negative classification which is done by our model. So these are basically the four quadrants within the confusion matrix. Now, what does this confusion matrix helps us with? Right. So confusion matrix helps us measure accuracy. So what is accuracy? Accuracy is a fraction of predictions a model got right. Okay. So formally accuracy has following definition, like number of correct predictions divided by total number of predictions, right? So suppose our data set had a sample of say 100 records and number of correct predictions were say 80. So 80 over 100. Yeah. So that is 80% is the accuracy of that particular model. For binary classification, accuracy can also be calculated in terms of positives and negatives as follows. So if we go for the binary classification, it is true positives plus true negatives, this divided by true positive plus true negative plus false positive plus false negatives. Yeah. So that is a more technical definition of accuracy. Now, accuracy alone doesn't tell the full story. When you are working with a class imbalance data set, where there is a significant disparity between the number of positives and negative levels. So, class imbalance data set means you might have a test model where the ratio in which the survived and people and the passengers who have not survived may not be an exact match. That is why we call it as class imbalance data set. We look at two better metrics for evaluating class imbalance problems. So we have two other better metrics which can be used in such cases. So those are precision and recall. Next we look at what is precision and what is recall. So what is precision? So precision answers following question for us. Like what proportion of positive identification was actually correct, right? So what does that mean? Like suppose our model has identified positive identifications, like say 80%. Out of that, how many were actually correct? Like if a model out of 100 it said like 80 people had survived. So since it is a test data, we know what are the actual results. So that gives us the precision of our algorithm or the model which you have trained. Precision mathematically or as a formula we can define as precision is equal to true positives divided by true positives plus false positives. Yeah, a model that produces no false positives will have a precision of 1, right? Because it will be TP divided by TP, so it's 1. On this slide, we are going to look at what is recall. So, recall answers following question. What proportion of actual positive was identified correctly? So recall is defined as follows. Recall equals true positives divided by true positives plus false negatives. A model that produces no false negatives will have a recall of 1.0. So it's accuracy of 1. That's what we can say. So that's about it for now for on demystifying the confusion matrix. If any questions, queries, do pour back your comments and I'll try and respond back to all of them. Thanks for watching.